My name is Shreya Jain, and I'm a junior at Middlesex School in Concord, Massachusetts. My project is using Google Trends data to predict how many people will get the flu 3 weeks in advance. The influenza virus is a huge problem in the United States as it infects thousands of people every year and also kills thousands of people. So it's important for doctors and hospitals to be able to anticipate how many people they're going to have to accommodate for in advance. The Google Trends data that I used includes data of search terms like flu, influenza, and other flu symptoms and flu medications as well. In total, there were 26 features that I used. I got my truth data from the Center for Disease Control, the CDC. The CDC's data is very accurate as its data sets draw from the hospitals and testing centers from across the country. So, the first model I made is a decision tree regressor. I trained this model on Google Trends and CDC data from March 2005 to March 2015 and tested on data from March 2015 to March 2020. Here are the test results. The y-axis of this graph is the number of cases of influenza normalized from a scale of 0 to 1. This model accurately predicted the number of cases in 2016, 2017, and 2019, along with this off-season time. However, it inaccurately predicted the 2018 and 2020 seasons, and it dramatically missed these peaks by about 8,000 cases. The model's root mean squared error, which is the distance from the points, the predicted values, to the actual value on a graph, is 1,330, which overall is not a bad score considering that the data's peak is at 22,000. This graph plots the values that my model predicted against the true values. Ideally, the actual and predicted values are the same, and in that situation, the slope of this line would be 1. The slope of the line of best fit through this data is 0.82, which is close. However, these two graphs show that the predicted values seem to cap off at about 13,000 cases. This means that it's not an accurate model at all for predicting the peaks of a season, which is the ultimate goal of this program. So I decided to make a random forest regressor as well to see if I could make a more accurate model. The random forest regressor uses multiple decision tree regressors, so I thought that it would better predict the peaks and that it wouldn't cap at a certain value. I made a program that found an optimal max depth value for this random forest regressor by maximizing the accuracy, which usually means a larger max depth value, and minimizing the model's proneness to overfitting, which usually means a lower max depth value, and this max depth ended up being 4. Overfitting is when the model is too closely tied with the data that it's trained on so that it's not effective making predictions on new data. So I initially thought that this new model would not cap off at a max value. However, it did, and it capped off at a lower value than the decision tree regressor did, at around 12,500, which made it more inaccurate, and it ultimately had an RMSE of 1568. The slope of the actual value versus predicted graph is also worse, and it's 0.77. So, in the end, I decided to try a completely different type of model, and I made a neural network. This neural network had 9 layers, including 4 leaky ReLU layers. This model yielded an RMSE of 610, which is less than half the RMSE of the decision tree regressor and 40% of the random forest regressor. While it performed with less accuracy than the random forest regressors and decision tree regressors during the off-season, it is significantly better at predicting the peaks of the actual flu seasons. While it falls short of the peaks in 2018, 2019, and 2020, it accurately predicts the shape of the peaks. The measured versus predicted graphs has a slope of 0.87. Considering the fact that the peak is around 22,000, the RMSE of 610 is actually quite small. It's about 3%. Overall, this neural network accurately predicts the number of people who will have the flu 3 weeks in advance. This type of work could also be applied to predicting how many people would have another type of disease, including the current coronavirus, which is spreading very fast right now. The Google Trends data would be different search terms, symptoms of various strains of the flu, and then that could be used to help predict which vaccines would be more needed during a given flu season. Moreover, this could also be used to offer insight into what Google Trends reflect about the problems that humans are facing. And another area is that if this Google Trends data was used to predict the spread of the flu in different regions, for example, Boston versus New York, this could also be applied to predict how the flu would spread across the country. So it could start in New York and then spread to Boston. And this could be all done 3 weeks in advance, which would be very helpful. Thank you.